Dissecting Catfish Fins, the hidden world you've never seen. Chapter 1. Opening the invisible world. Have you ever really seen a catfish? Seeing it up close. So close, in fact, that you can dive into what's hidden beneath its skin. We're about to embark on a scientific expedition, pushing the limits of the naked eye, to uncover the mysteries hidden within one of its most overlooked body parts, its fins. At first glance, it's just a fin, dark on top, clear underneath. Brace yourself. We're about to dissect the secrets of nature hidden within the catfish's fins. A tale of camouflage, defense, and the most brilliant bioengineering. Chapter 2. More than just an oar, functional architecture. Why do catfish fins have different shapes and more than one? These fins aren't just paddles. There are pectoral fins next to their heads. These aren't for swimming. These fins are short, hard, and sharply tapered, called barbs. They're a defense weapon. There are also long dorsal and anal fins, extending almost to the tail. What's their function? Not for speed. These fins serve as balancers, keeping the catfish's slippery, rounded body from tipping over and rolling when maneuvering in narrow waterways. Then there's the tail fin. This rounded shape is a master of acceleration. It allows the catfish, an ambush predator, to create a sudden burst of speed from a standstill to pounce on its prey. It's designed for sprints, not marathons. Chapter 3. Black and clear illusion, the perfect silhouette strategy. Why are the tops of the fins black, but when flipped over, the undersides are clear? This is a survival strategy called countershading, or countershading camouflage. Imagine a predatory bird flying over the water. It swoops down. Its eyes will see the dark, muddy bottom. The black body and fins of the catfish on top will blend perfectly with the darkness. It's a living optical illusion. The secret? Black pigment cells called melanophores are concentrated only in the topmost layer of the fin skin. The layer beneath is pure, transparent collagen connective tissue. Chapter 4. The black spot forest and the invisibility membrane. We've certainly noticed the incredible number of jet black spots. These aren't dust or dirt. They're melanophores. Under the microscope, they look like tiny, dark stars, with branches extending in all directions. Their numerous numbers on the upper fins act as a double defense, providing perfect camouflage and protecting the delicate tissue within the fins from the sun's damaging ultraviolet radiation. Then, between the fin spines, a thin membrane stretches. This membrane is clear. What's its function? It's the interradial membrane, a biological screen that unites all the fin rays into one solid paddle surface. Look more closely. Above this silent, clear membrane, there are few isolated black spots. These are stray camouflage pawns, tasked with breaking up the silhouette of the catfish's body so that the dark pattern doesn't stop rigidly, but rather merges gracefully into the clear membrane. Chapter 5. The mysterious red spot and the riddle of the clear bone. What happens when we find those strange pinkish red spots we've been seeing under the microscope? This is a crime scene. Those red spots are blood. The red blood cells of the catfish. When the fin is cut, the tiny capillaries at the base of the fin are also cut. Blood gushes, seeps, and leaves a dramatic pink trail under the microscope lens. It is living tissue that breathes and receives a blood supply. We've probably already seen the framework of this membrane, the fin bones. They aren't solid, rigid rods, but rather segmented, jointed, just like sugarcane but translucent. Each segment is a segment of cartilage connected by flexible tissue. This design provides the perfect combination of strength and flexibility. The fin can be bent, folded, and moved in precise waves without breaking. And look at the color, clear, translucent. These fin bones are mostly pure collagen. Their transparency once again supports the fin's primary mission, to move silently and unseen. Chapter 6. Living ink, catfish emotion screen. Earlier we discussed black spots. Then we also saw something that looked like a black ink spill. Why is this black color different from what we see now? The answer is the culmination of our entire journey, and it's what will amaze us. The black spots and the ink spill we see come from the same cell. Yes, the same melanophore. This is a living, dynamic cell. When a melanophore cell contracts, all its melanin pigment granules are tightly packed in the center of the cell. Under a microscope, this is what we see as dense black spots. However, when this cell receives a signal from a fish's nerves or hormones, it relaxes. The black pigment granules immediately spread outward through its branches, filling the entire cytoplasm of the cell. The result? A large, irregular spot, just like spill ink on the floor. This is not a defect, it is a feature. This is the catfish's emotional and adaptive display. In a matter of seconds, it can change its color pattern to blend in better with its environment, communicate with other catfish, or respond to stress. Chapter 7. Conclusion. A fin, a masterpiece. Our journey has reached its end. From a tiny piece of a catfish fin, we have uncovered an epic chapter about life itself. A simple phenomenon in catfish fins turns out to be a masterpiece of biological engineering. This is evidence of complexities often hidden in the most remote places. That's all from our discussion. Don't forget to like and subscribe and share with people around you. The world is not short of wonders. What's often lacking are eyes willing to look deeper. Thank you for delving into hidden worlds with us. We hope this is helpful, and we look forward to seeing you again in the next, more mysterious microscope adventure. See you in the next video.